Okay, hi everyone. Welcome to the Solar and Energy Storage Market Series. My name is Kyle Pease and I'm a Sales and Design Engineer here at RENVU. Today we're going to be hearing from Andres Franco, CEO at Isigenere, about their floating solar racking solution. Before we dive in and while we're waiting for more people to join, I'd like to give a little background on RENVU, as well as some of the products and services we offer. RENVU is a US-based solar equipment distributor. We've been in the industry for over a decade, and we currently have fulfillment facilities in California, New Jersey, and Texas. Our sales staff all have technical backgrounds within solar and engineering to provide you with the best sales service. A few products I'd quickly like to spotlight here, and we'll share links in the chat as I go. First off, we're very competitive with Enphase products. We have IQ8 Plus, M, A, H, and then some of the new commercial options coming up and all the balance of system components as well. So email in if you're looking for any of those. We have rolling promotions for those each week or two. So keep an eye out. We also have SolarArc products, the 5K, 8K, 12, 15, and now 30 and 60K commercial options. We do have a promotion on those right now. If you buy a Fortress eVault Max 18.5 with a SolarArc 15K or a Fortress MV True 12K, we'll send you 15 free Hyperion 400 watt black on black modules as well. Also, we have a bunch of Xeonshine 550 watt bifacial modules. When you buy SolarArc 30 or 60K along with those modules, or even we can do the Selectria. They have 25, 36, 50, and 60 kilowatt options for either 208 or 480 volt, depending on the inverter size. We'll give you 10% off of the modules you buy for your project with those. We also have Powerfield ballasted ground mount racking for an easy, quick install option. And then we have a variety of Tigo module level electronic devices. So email in if you're needing some of those for your upcoming projects. We'd be glad to help you out. And our email info@renvu.com. I think we'll share that in the chat as well. Next up, here's our commercial price list for our large volume purchase options and some upcoming offerings. We'll share a link in the chat to this page. It's a good one to bookmark if you're an installer looking to re-up your inventory, or if you've got a large project coming up in the works. These are some buying options for you. We keep updated regularly. Okay, one last item to go over before we get started, and I'm going to jump over to our website here actually. So I spent a lot of my time here working with this tool. It allows you to generate quotes with modules, racking, inverters, etc. First off, on the start page here, you can choose from a full system or a subset thereof. If you already have modules, you can deselect those and put the characteristics in the next page. For now, I'm just going to go with a full system, and we're defaulting right now to the Hyperion 400 watt modules. Those are our best price option. As you go through here, when you're logged in, you'll actually see prices populate on the right hand side and dollar per watt, so you can get a metric to compare the different costs of these modules. To make your selection there, I'm going to leave it on the Hyperion for now. And then on the next page for racking, we offer pitched roof, flat roof, carport, ground mount, and maybe we'll see a floating solar at some point. We'll see how the interest goes for these, but I do work with our web development team to put in these options and the logic that goes through populating the bill of materials you see here on the left-hand side. So for under pitched roof here, we have a variety of different roof surface types: comp shingle, Spanish tile, flat tile, metal roof. As you make your selections, it'll change the bill of materials and your price, so you can compare between different options. Under flat roof, you can choose between tilt legs, ballasted, or metal roof. And then for carport, this is a cool option we have. BLIKIR is now in their 5th generation of their 2-car carports. And if you're curious about any of these options as you're going through, you're not sure what an item is, you can actually click on it and it'll save your where you are. It'll just pop up another page here that'll show more about that specific product so you can learn as you go. It's a really nice way to get educated on the materials that are populated in the quote here so you can understand how it all fits together and works here. This BLIKIR 2-car carport is engineered and fabricated in the U.S. with U.S. steel, so it is eligible for the 10% ITC. Each of these products, you can look at the documents below if you need to see installation manual of how it works, data sheet, or any of the certifications. We provide those there as well to make it as straightforward as possible when you're going through and selecting your options to make sure you understand what your selections are. So I'm going to leave it on. Actually, let me show you the pitch roof real quick. It's kind of a cool option. You can select the number of rows, choose between landscape or portrait layout, and then you can change the color of the racking and the roof attachment item there, as well as the grade of the rails. For this demonstration, I'm going to leave it on the BLIKIR carport. And actually, I'm going to do a 2-car carport, or a 4-car carport. So that's 2 of the 2-car joined structures. You'll see it populate there. 1 of the 2-car, and it should show 1 with the tandem. So that will share columns for 4 cars. All right, and then for inverters, defaults to microinverters, IQ8M, which is a 1.23 DC to AC ratio with those Hyperion 400-watt modules, so that's a good default selection. If you want to go a different route, we have optimizers and string inverters to choose from there as well. And also, you can add on energy storage if you like. Then on the next page, you can choose if you need some spare panels. I highly recommend this as the inventory is constantly changing and it can be hard to chase down a module. If you have one break a year out, the supply is always turning over. So I do advise on that. We have options to add in EV chargers, Lumen Smart Panel, as well as balance system components there. Then you're able to review your bill of materials. You can hit this button to generate a quote. You'll get a copy in PDF and an email as well with it, and you can respond to that. That'll come to me or one of my teammates, and we'll look it over and give you some guidance if you have any questions, check it over for availability and all that, and help you move forward on proceeding with that quote. All right, so back to the webinar here. Let's see. So if you have any questions about these projects or about Isigenere while Andres is presenting, please feel free to ask in the Q&A section, and we will get to those questions at the end of the webinar during the Q&A session. You can also email our sales team at info@renvu.com for more information and pricing. This webinar is being recorded, and we will send you a link in a follow-up email. We also have recordings of previous webinars on the RENVU YouTube channel. So without further ado, I'll hand it over to Andres.
Okay, thank you, Kyle. And thank you, RENVU, for the opportunity to discuss today about floating solar and what we see it's the potential for the US market and how we can support you in your floating solar projects. Basically today, what I want to share with you, it's starting a little bit about floating solar, some of the benefits and challenges that the technology presents. I will introduce our company, Isigenere, and our technology, Isifloating. I'll discuss a little bit about the potential of the US market for floating solar, which we believe it's really interesting for the future, and give you a few tips on how to get started with floating solar and where to look, how to do it. So let's start with an overview of floating solar. And even though this is a new technology, this is already something that in certain countries is becoming kind of mainstream. At the end, a floating solar plant is nothing else than the traditional PV panels, inverter cables that are put on top of some sort of floating structure that support the weight of those components as well as the weight of the people doing O&M, potential snow loads, wind loads, wave loads, in a way that it's able to manage all those loads at the same time while it's anchor and moor to the bottom or to the side, depending on the type of reservoir. So what it's different in this type of project is the type of structure and the anchoring and mooring solution that is defined for each project. There is significant potential for floating solar. This is an interesting study from the World Bank and the Solar Research Institute of Singapore that they were looking at only the man-made reservoirs, not looking into lakes, not looking in the ocean, only man-made reservoirs. And what would be the potential for floating solar if, for example, in this case, only 10% of the surface was covered? And in this case, with 10%, the potential would be that you could install more than 4,000 gigabytes of floating solar. And later we'll talk about the potential for the US. So why floating solar? Why are people betting on using this technology? There's three main benefits. The first one is related with the cooling effect of the water being close to the panels. And in this case, it increases the performance of the PV panel. How much? Well, it ranges depending on the condition of the site and also the condition of the structure. In Singapore, they measure up to 18% in a test bed that they have. Singapore has a lot of humidity, so the cooling effect is much higher. In Europe, that is a little bit drier. We are seeing number between 5 to 10%, depending on the size of the reservoir. If it's very deep, the cooling effect is higher, and also how far the PV panels are from the water. Second benefit, it's on water, and this reduces water evaporation because the sun is hitting on the PV panel, and this might be relevant for certain applications, for example, in the agriculture or also water management companies that water for them is a main resource. And also there's a second benefit related with the quality of the water, that this reduces in general the proliferation of algae, and therefore it reduces the chemicals that you need to put to prevent algae and other microorganisms from appearing. And the last benefit, kind of the obvious, is not using the land for the solar project. Keeping the land for the original use, it could be agriculture, livestock, and then also reducing the visual impact. In certain places, we're seeing this in France, in Italy, they are getting more and more concerned with the potential visual impact, and they believe that floating solar could be a good solution for such situations. As anything in life, there are also challenges, and nothing is perfect. So the main 6 challenges that we have seen in our 15 years of experience are this one. So first, starting with the adaptability, the fact that water level goes up and down, and you need the structure and the anchoring and mooring solution to work perfectly at any condition of water level, sometimes even with no water. I'll show you some examples later. Then the logistics, even if everything is produced in the US, moving goods from one side to the other of the country, the cost of the logistics is high, and you don't want to pay for air being transported from one place to the other. There has to be good, efficient, from a logistic perspective, solutions so that you reduce the cost of the logistics. The third challenge is the installation. There are not a lot of companies that are specialized in the installation of floating solar. So the easier the floating structure is, the better for the cost and also for the quality of the installation, so that the installation of the system can take just a few weeks and can be scalable. It doesn't require a lot of space. Those are some of the challenges related with installation. Then moving to maintenance, it's very relevant, and this is something that is becoming more and more relevant as the plants are aging, the safety and easiness for people doing the O&M, especially related with the buoyancy of the structure. What happens, not just when people are walking and doing a visual inspection, but what happens when you need to change a PV panel, to change an inverter, a combiner box, will there be enough buoyancy and stability for workers to do that in a safe way? And the last two challenges related with nature, first being able to integrate in a good way with the existing wildlife, and that means that sometimes you cannot cover a large percentage of the water body, depending on the type of wildlife that exists. There are already some interesting studies, for example, one in Taiwan, where they cover 60% of a fish farm. The fish were in a cage, they cover 60% of the surface with floating solar, and the impact was no fish died, but the growth of the fish was reduced by 5 to 10%, depending on the season. But still, the benefits of floating solar outweighed the potential reduction in the growth of the fish. And the last challenge is the most complex one. It's the floating solar needs to resist nature. And floating solar projects are in general more complex because you have the wind and creating the wind load, you have the sun that degrades the structures, you have the waves, and not just the big waves, but also the small wave that create fatigue in the effect. You have this movement, constant movement of the water that induces fatigue in the components. And when this happens thousands or millions of times in the lifetime of a plant, this can lead to failure. So how to cope with that, with the forces of the anchoring and mooring to the structure. And these are the 6 main challenges that we have been studying and coping in the last 15 years. I don't want you to get concerned, but just to be relevant that if you don't take into account the design, the wind load, and how to prevent all of this, there can be failures. And there have been some failures on plants worldwide of things going bad. It doesn't mean that it's always like this. If you do it correctly, it will work. And however, what we are seeing that there are 2 aspects behind some of these failures. The first one is that many people that are coming from the solar world, they want to maximize energy production. But when you are doing that, if you are putting the panel at a higher tilt, basically the panel becomes a sail. And when you have thousands of sails, your floating solar plant, it's more like a boat that wants to move with the wind. And that means that the wind load increases by a significant percentage. Here you can see we started our first floating solar system was installed at 10 degrees and the back of the panel was open. But this is something that we have reduced a few years ago. We have moved it to 5 degrees and we have closed the back of the panel. So when you compare the wind load, the CP factor that engineers calculate with other systems, let's say at 12 degrees and open back of the PV panel, in these systems, the wind load goes up by 440%. So the wind load grows in a quadratic way. So it's very, very significant increase. So our recommendation is to go for lower tilt. Similar what is happening also in rooftop installation, that more and more the installers are putting the PV panels at lower tilt because of the wind effect. And the second issue is that the floats are also structure, and the thicker the structure, the more resistant and robust it is. And here you can see a couple of examples of other technologies with different thicknesses. We are betting for a minimum thickness of 2.4, and there are parts of the floats and the structure that have 3, 4, even 5 millimeters in part that are key, and that they suffer the highest mechanical stress or the fatigue in the system. There are other things that you need to think about. What will happen if water goes down? And maybe you say, well, I have this control, or the owner of the pond knows what the historic. Nobody thought that the Colorado River was going to run out of water. So this can happen. And this is an example of a system with a metallic structure that water went down, and at the bottom there were big rocks. And because it's metal, it bends. And when water goes up again, the structure is still bent. So it's important to think about the flexibility of the structure, not only because of the fatigue, the mechanical stress, but also because water at some point is very likely that will break minimum historical records, and you need something that will reduce the potential impact on the structure. Other key factor, the buoyancy. Here you can see examples of, for example, here on the left top, with just the weight of the string cables on the adjacent float, it's putting this float at the same level as the water. So any worker that goes here, they will be partially submerged 10, 15 centimeters. Or you can see here in this picture, these two guys, they are already a little bit under the water. So we believe that this type of solutions, even though it reduces the cost, is not the safest for workers. And workers don't like to be doing electrical works and at the same time touching the water. And even if it's just a visual inspection, just in this case, the weight of this person moving, yeah, it's putting enough pressure on the float so that he's touching the water. So for us, buoyancy, it's relevant. And the US is even more relevant because you might end up in an installation with snow load. And the snow load can be even higher than the weight of a worker or two workers moving a PV panel. So let's talk a little bit about Isigenere and our technology, Isifloating. So let me start first saying that in Isigenere, we started in floating solar in 2008. And this was the first floating solar plant that we installed in 2009. This plant is one of the oldest in the world. The oldest commercial system that we know was installed in the US, actually, in a winery in Napa Valley in 2008. And this system is from 2009. Since the first system that was installed with our technology, Isifloating, we started seeing some of the challenges of these floating solar installations. For example, that water level can go down. You see here some of the PV panels resting on the slopes, the relevance of buoyancy, the wind load. During the first 3 years, this structure didn't have any issue at all. But after 3 years, we started seeing some of the challenges. For example, the wind load hitting on the back of the PV panel. We started seeing with the fatigue that the floats were being connected directly by some ears. And we started seeing that there was fatigue of the movement of the water and that in the corners of the float, there were white lanes appearing. That's an indication of fatigue. So this was with the first version of the technology. We are right now in the 5th iteration of our technology. And we have learned a lot of this. So Isigenere is basically a manufacturer of floating solar systems. The racking system, we also provide the anchoring and mooring solutions, and we also provide engineering services. We have right now 2 manufacturing lines in Europe, and we are in the process of opening in the first semester of this year a manufacturing line in the US, so we can provide you with solutions made in America. We have tested our technology in many different type of reservoirs already. I'll give you a glimpse of some of the type of project that we have done in different type of reservoirs. The way we work is we are trying to create an ecosystem of companies that we cooperate to bring floating solar projects to the end clients. So that means that we are not vertically integrated. We are not trying to do development. We're not trying to do EPC. What we do is we work together with other clients that they provide EPC services, they do the engineering or they do the financing, they are the developers. And we provide our knowledge as a specialist in floating solar structure and also anchoring and mooring. So in that way, you can also feel safe that we will not become your competitor in the future that trying to provide EPC services or fully integrated development services. Basically, in a project, we provide 3 big services. One, we do the engineering and the technical design of the floating solar structure, looking at the conditions of the reservoir. And also, we do the design of the anchoring and mooring, everything related with the calculations. Second, we supply the floating solar structure, everything related with the floats, the clips to connect the PV modules to the structure, walkways, and also the item related with the anchoring and mooring system. And finally, we provide the training to the EPC or whoever you choose that will be the installer of the system. And we have offsite online training. Then we go on site and work together with the team that is in charge of doing the installation. And at the end, we do a quality control of the installation done by the EPC or the installer. This is a glimpse of some of the projects that we have built we have already projects in 4 continents around the world. And I wanted to go a little bit more in depth on some of those projects. For example, starting with this project in the Netherlands, this is a 7 mega project in a lake in the Netherlands. This project has some challenges related with snow load. Another challenge was to maximize energy occupation, at least fulfilling the environmental concern that the local authorities had. This is another example in Spain. This is for a water management company that provides water for 8 million people in Spain. And this is one of their reservoirs. And this reservoir is an artificial reservoir that can get empty a few times during the year. And also, this is a historical installation. So we also needed to do an anchoring and mooring solution that was preserving the key architectural concerns that the owner of the reservoir had. This is a project in Chile, and this is for the 5th largest winery in the world. And this is a project where you can see that every summer it gets empty and the system rests at the bottom. For this project and the client, one of the main concerns was the reduction of water evaporation. Our system right now, some of the measurement that we have done is reducing about 80% of evaporation on the surface that is being covered by the system. Going to more complex environment, this is in a dam, one of the largest dams in Europe. This project is for EDP, the Portuguese utility. It's a 5 mega project and it's in a dam. The anchoring it's happening at almost 210 feet, 70 meters. The water level variation, it's around, it's more than 65 feet, 23 meters. And because it's so big, the dam, when the wind blows, it can create waves that can be from 1 to 2 meters. So this is a very complex reservoir. And the solution that we provide and install actually won the prize for the most innovative project from the European Union in 2023. And we have one project already in the US, in a dam in Oklahoma. This is a project to integrate aeration systems into the floating solar array. And it's interesting, this is an easy day in the dam where there is very little movement, but you can still see that with the small waves, there is a lot of movement going on in the floating solar structure. So imagine when you're having the half a meter, 1 meter waves, and how it needs to move constantly. And when this is happening for many, many years, you can get an idea of the significant fatigue that is induced into the systems and also the mechanical stress in the components during the lifetime of a project. So if we talk about our technology, we have been working since 2008. This is an overview of the evolution in our technology. We have used many different types of manufacturing for the floats. We started, as I said, with floats and metal structures that were being connected between them. Now we have moved to mainly a polymer type of a structure that already the tilt is incorporated into the float so that there is very little friction. One of the things that we saw in the old installation was with the movement of the water, when you have metal parts and also you have polymers, there is a slight friction happening. And depending on the condition of the site, this slight friction might, after many years, can start breaking the components. So this is similar to the metaphor when an inmate escapes from prison with a spoon. It's not because they are hitting the wall, it's because they are eroding very slowly the material. And this is the same that could happen depending on the condition of the site, that the metal will start eroding the polymer and can create some challenges for the structure. This is how our system works. Every PV panel is supported by 2 floats. This increases the buoyancy and it's good for the snow load situations. The floats are connected to the PV panel with, by some clips that are designed by us, and that these clips try to reduce again the movement and the potential separation of the PV panel from the floats after the fatigue and the movement of the water. Every PV panel, when it's attached to 2 main floats, that's what we call a floating unit, and other floating units are connected by these black connectors. These black connectors are made of fiberglass and nylon because these parts absorbs better the mechanical stress, and also they're better at coping with the fatigue and the movement of the water. And then we have secondary floats. These secondary floats are used for the walkways, to support the cables inside the floating solar structure, to support the inverters. And these floats have an even higher buoyancy. And the buoyancy of these floats are more than 135 kilos per square meter. So if we talk about the key differentiator of the technology, the reason why our clients are choosing our technology is mainly because we have tried to work on a system that will provide the highest quality and durability. There is no commercial installation that is older than 15 years. So we have made conscious decisions to increase the quality, the safety, the adaptability, at the same time to be cost efficient. So let me talk a little bit about each of those items. If we talk about quality, we are using an injection molding process to create the main floats. And that's because that gives higher precision and durability. Injection molding is used in the aerospace or the high-end automotive industry for parts that have a lot of precision. We also are betting on having higher thickness in the floats, because the floats need to be also structured. They don't not just need to float, they need to absorb the mechanical stress. We have 2 floats per each PV panel. We require that the PV panels that are put on the system need to be frame PV panels. We don't support frameless PV panels. And also we are using HDPE, high quality HDPE. We put UV additives and anti-oxidation additives to increase the lifetime of the system. And given that we have using injection molding, we can very quickly support and provide the floats for any system. So every PV panel, every mega of floats, we can produce them in less than 5 days. So we will not be a bottleneck for your project. When the PV panels are arriving on site, you will have the floats to start the installation. And we have done significant testing of the technology, testing on the materials, the density, the flow rate, the tensile properties, accelerated UV systems. The system is compatible to be with water for human consumption. We have also done testing on when do things break, and not just the obvious, the float, but also small parts, the connection plate, the screws, the nut, because in floating, everything is connected to each other. And we have done even more complex testing, like this one in Europe, where we have installed our system and in a massive tank that can recreate waves, and we have put sensor. And this is the type of testing that we have done to understand where is the mechanical stress happening and what's going on with the fatigue. So here we're simulating big waves, and also the key part, high frequency waves. When you have one wave coming right after the other, this is a good way to understand what's going on with the fatigue. And you can see that the system, the idea behind it, the system will be flexible and will be surfing the wave in order to dissipate the mechanical stress. Because we believe that if you concentrate the mechanical stress after many cycles and the fatigue, it will break. So it's a lot about the dissipation and the reduction to make the system as aerodynamic from the perspective of the wind loads, the wave loads, and the current loads. And this is something that we have done in control environment, but we have also installed the system in places with significant waves. So here you can see this is a system in a big dam, and this system is protected by a wave breaker, because this place you can get waves up to 2 meters. And even though the system on the side breaks the wave, you can see inside that there is still quite some movement happening in the structure. And again, that's why the flexibility of the system to adapt to the waves and dissipate the mechanical efforts, it's relevant. And we have worked with external companies. In the US, we have worked with Black & Veatch that has done independent assessment of our technology. And it's not just Isigenere saying that this works well and this can support X buoyancy, X wind load, but also we have a third party, Black & Veatch, who has tested and done assessment of the technology of our suppliers and how we are using and the technology and the design that it's in the back of our floating solar plants. Let's talk about safety. Safety for us means two things. Safety for workers when they are doing the O&M. Remember the picture I show you, one guy is stepping and already touching the water, two guys. So here you have 9 people, one right next to the other, and you can see still the distance from the water to the edge of the float. So the buoyancy in our system, this is one of the key differentiators. We think it's important from a safety perspective, but also you can get an idea that if you put cables on top of this, if you put string inverters, and then when workers are doing the O&M, they will not be touching water when they are doing electrical works. And also for us, as I mentioned, the 5-degree tilt and the back of the panel close is a safety feature. This reduces significantly the wind load. We know this produces a little bit less energy where depending on the latitude than system at a higher tilt. But we think it's important and more relevant the longevity, the durability of the system, and that the cost of the O&M will be significantly lower. In the picture that I showed at the beginning with the failures, you can imagine the significant cost that the companies had, also the loss of production for several months. So we bet and we believe that 5 degrees of tilt and the close of the back reduces significantly the risk of floating solar plants. Then talking about adaptability. We don't know what's going to happen with nature. This is an example of a floating solar plant where the owner said that the water was never going to go lower than this black part. And it was never like that until it was. And the water went lower than expected. And the system, our system is able to rest on the slopes of the reservoir because of the connectors made of fiberglass and nylon, and also was resting on top of the tubes of the entrance and exit of the water. This is something that if you don't have a system that can cope with this, if only happens once in the lifetime of the project, there will be significant damage. So the idea is not that the floating solar plant will be working like this the whole time, but in exceptional circumstances, it's better to have this possibility. And nobody knows what's going to happen with the dry seasons in the future. So better to be ready in case to manage this situation. And in large ponds or where there is significant water level, we don't use the traditional ropes and mooring systems. We use flexible mooring system. We have a strategic partnership with a Swedish company called Seaflex that they are leader in this type of mooring. When you see this comparison of a traditional anchoring and mooring system with the flexible one, when water level goes down, there is a slack in the ropes. So there is more movement on the vertical and the horizontal compared to a flexible mooring system where there is some movement, but it happens in a more controlled way. And why is this relevant? We believe this is relevant because when you are at this moment, I'm going to pause the video here. At this moment, there is a sudden pulling from the ropes or the chains that are in the anchoring and mooring system. And this pulling can break things. Here you see a measurement. The yellow and gray dots are the elastic system, and the blue and orange is the traditional non-elastic system. So in the elastic, it's already pre-tension. So when the wind happens, there is a gradual absorption. While on the other, on the non-elastic, there are these peak moments. These peak forces, it's what breaks components. At the end of the forces, both systems tend to stabilize at similar workloads. But it's these seconds that when the peak forces are happening, that reduces the durability of the components. And we have measured that with the elastic system, we can reduce about 70% the peak loads in the system, increasing the durability of the project. Finally, the efficiency in cost. And we are not just talking about the cost of the floats. We have our design of the float, given the quality, the durability, is not the cheapest system. But what we're trying to do is that the overall cost of the system and the project will be competitive. And there are two items to keep in mind. One is the logistics. Here you can see how our system and the main floats are shipped. You can put one float inside each other. So in one column, you can put 45 floats. And here you can see other technologies that can put 12, 16, 18, depending on the technology. So that means that you might need 3 to 4 times more containers or trailers. And this translates into extra cost for your project because logistics is kind of a commodity. So here you see a table thinking that the cost of the transportation of one container or trailer, it's 2,400 euros. And here you can see that the extra cost could be between 4 to 6 euro cents per watt peak, just on logistics. So even if we quote the same price as other technologies, we are paying less logistic costs. So that means that the other technologies, in order to manage that difference, they have less material, they have the quality of the material is lower, because at the end, the logistic cost is something, this money doesn't go to you, to us, it goes to the logistics company. And we want to reduce as much as possible the logistic cost. And then in the installation, is done, most of the installation is done inland. Here you have a time lapse where you see further reduced space that is needed to do the installation. And this is a very, very speed process where the learning curve is low. In our technology, on average, 1 mega is being installed by a team of 5 people in 15 working days using panels of 550 watts. And the type of materials and tools that are used are very easy to find materials, and the productivity is achieved very early on. After you have about 50 kilowatts, the workers learn how to install the system, and they achieve that productivity of 1 mega in 15 working days. And of course, if you can do this faster, translate into lower cost. And here you can see taking productivity rate from other systems and how our system compares, and it can give you with a $35 per hour what can be the different costs. So it can be between half a cent to 1.5 cents per watt peak. So here we have talked about two costs, the logistics and the installation, that can probably give you saving between 5 to 7 cents per watt peak. So you need to look at this when you are looking at potential technologies to make sure that you're optimizing not just the cost of the float, but also the cost of the logistics at the installation. And there are other hidden costs. For example, you don't know what's going to be the water level when you do the installation. So if the system is flexible, you can install it directly, taking advantage of the slope, and you don't need to build installation ramps to put a maximum on the tilt of the floats. So this is something important to keep in mind. And also sometimes there is not enough space in the reservoirs to do the installation. So if the system is compact, that means that you can install it. And here you have a couple of examples where there were just a few feet of width in the area. And this is becoming more important because some environmental agencies, to get the environmental permit, they are asking how much space needs to be clear in order to provide the environmental permit of the installation. So the lower, the smaller the amount of space that you need for installation, also reduces storage cost as well. And then if we talk about maintenance, how to do the maintenance, the walking, we have built a system with analogy of highways and streets. The floats, the secondary floats, are what we'd call the highways. You can put many highways, and we can sell you a lot of secondary floats, but highways are expensive. And well, we think that it's better to invest the money in the main float, that are the floats that are supporting the PV panel, that are the structure, and that those are the floats that are working 24/7, managing the structure, the mechanical load, and the fatigue. And let's suppose that somebody needs to go into the middle of the installation. They work by the space that is created in the streets. The street is the space that is created when you put two main floats together. So this is the way how a person moves between that. So in this way, they can get to any point of the installation in a safe way. If you want to have the comfort package, we can put more secondary floats every 2, every 4, every 8 rows of PV panels. But we think that if you're just very unlikely going to be in certain places, this is a solution that will optimize the overall cost of the O&M for the project. And if you need to do cleaning, especially for large plants, we recommend going directly for robots. And here you can see example of robots moving on top of our technology. You can see these robots might be 200, 250 pounds, and they can move independently from one PV panel to the other. They can go on top of the secondary row. Some of these robots can even turn in its own axis and move to the next row of PV panels. And this is relevant. It's only one guy doing the support of the robot because they need to change the battery. They need to guide the robot. But with this robot, with only one guy, you can be cleaning 1 mega every day. And again, the buoyancy is relevant. You want to have enough buoyancy. So for example, in this video, the guy can bring all the tools, and imagine this could be the tool, but they could bring an inverter, a PV panel, and the buoyancy will be enough and the stability of the workers to do it in a safe way. And to give you an idea on how the same robot works with a different technology, here you see the same robot with other technologies, and you see the amount of movement that is happening, the safety for the worker. They need more than one worker to do that, and you see how they are stepping here on the right. So it's not as easy as working as our technology. And if they need to move the robot to the next row, of course, they will need 2 guys doing the movement. And that also increases the cost of the system. Now let's talk about the floating solar market in the US. We believe there is significant potential for floating solar in the US market. There are a lot of water bodies that can be used. There are already more than 20 projects and more than 40 megas installed in the US. So the benefits of floating solar installation, we believe, have already been proved in the US, but the potential is even higher. NREL, they have released this paper where they believe that floating solar could provide up to 10% of the US electricity annually. And there is another study by several countries and Sandia National Labs where they believe that the United States has the largest potential for floating solar with more than 1.9 terawatt per year. And there are already certain states like California, Florida, and New Jersey where we believe the floating solar potential is higher because they have a significant amount of man-made reservoirs, they have high energy costs, or there's already some regulation that it's promoting the building of these floating solar projects. We believe there are 2 opportunities for floating solar. One is in self-consumption projects. So especially in artificial reservoirs where the energy produced will be used mainly for some sort of self-consumption. The industries like agriculture, water management, or industry, cement, steel company that they own artificial water bodies, they can use floating solar technology. Usually, they don't have enough space, or the cost of the space is high. You don't want to take out 1 hectare of crops just to put PV panels on that. You want to take advantage of the water body that already exists. Then they also need to preserve water. They need the water, for example, the water management companies, or they're paying a lot for the water, especially in industries like cement companies. So floating solar can be a good fit for that type of industry for self-consumption projects. And the second opportunity is for utility scale projects. These could be in dams or lakes. Depending on the state, there is already some regulation, or you need to have manage more uncertainty in the construction of certain projects. But this type of utility scale project, we believe they could be installed in, for example, hydroelectric facilities, like the one that I show you in Portugal, or the one that I have in my back, because there is some hybridization of the hydroelectric facility and the solar system. You can put it in quarry lakes, and this is a good story because in the past they were maybe polluting, and now they are producing green energy. or you can put in large agricultural reservoirs or public reservoirs that they can provide the permits so that you can install the floating solar plant in these type of reservoirs. How do we start with floating solar? So the first thing that we recommend is being careful with the site selection. Similar to ground mounted, not every piece of land is good for a ground mounted project. Not every water body is good for a floating solar. So here you have a few questions that we ask in each site to see if this could be a good fit for a floating solar project, to understand the shape of the reservoir, the area available, if there are environmental constraints, how big, how strong are the winds? Are they really hurricane winds? If so, you really need to look carefully on the possibility of installing this, not because the structure will not last one hurricane, but because maybe after the third hurricane, the fatigue, the mechanical stress will be significant and the structure might not work as expected. How strong are the snow loads? In our case, we believe that more than 20 pounds per square feet, it's really high snow loads. And sometimes we tell our clients that we don't think they should build floating solar projects in certain places of the world. There are many other different places that you should and you could install floating solar. How much freezing could happen? If it's just a few centimeters, if it's okay. But the other day we were looking at a site in the north of the US with 40 centimeters of ice. So we believe maybe not the best place to look at. It doesn't mean that it cannot be possible to find a solution, but maybe the solution will be so expensive that will not make sense from an economic point of view. How big are the waves that could happen? And waves can happen even inside water bodies. When there is a strong wind, there will be big waves appearing. And what happens with the water level variation? Could this at some point be even with no water? How do you manage that? What's going to happen? What is at the bottom? If it's a dam, maybe you're going to have rocks, you're going to have uneven surface of the bottom. Will the structure be able to manage that? And finally, of course, how close is the connection to the grid if you want to take out for a utility scale? Finally, to give you an idea on the economics, on one of the reasons why you do floating solar is not cost. Floating solar projects are usually more expensive than ground mounted. So this is not a competition between ground mounted and floating. On average, what we are seeing is that floating solar project can be 20 to 30% more expensive than a ground mounted. And this also varies a lot depending on the condition of the reservoir. It's not the same in an artificial reservoir or in a dam. But we can support you with the site selection to understand preliminary what are some of the costs so that you can plug this into your business case and check if this makes sense. And if we can continue the conversation, we can support you with preliminary design and better cost estimation so that you go and progress in the development of your floating solar project. Thank you very much for your time. Sandra, let's open to some of the Q&A that the audience has been putting. Kyle, do you want to introduce the questions, please?
Andres, I'm not sure. Can you see the Q&A list there? We've got, looks like 9 questions. Folks have asked. First up is William, if an install were on a retention pond where it floods and drains, is that okay?
Depending on the forces of the flooding happening, we are not so much concerned about the flooding because we can install elastic system that can manage the water level variation, but more about the currents. If the currents are strong, we don't advise to put this. You have seen, if we are concerned about the wind load, you have seen when there is a river overflow of the flooding of the river, it can break, it can bring and break trees, it can break bridges, it can move cars. So if the forces of the water at strong currents, it's something that you want to be away. Forces that maybe if you're looking at 1-2 meters per second, would say stay away of those places. The loads in the anchoring and mooring system will be very high. Okay, now I see the Q&A. Thank you. Second question, the grounding, how's it usually installed and connected? So this depends on many times on the legislation in each country. We have installed it in places where the lining rod is put on the floating solar. In India, they like to put it inside the water body. So this is something that usually we follow the recommendation and the regulation that the EPC already knows on each state or country. And the system can put the grounding in many different ways. It can be on the island or under the water as well. The next question, they talk about experience. What's our experience and taking into account the current state of the US market? What specific type of project or business case would you suggest focusing on? So as I said, there are two types of projects. One is the self-consumption, that if you're looking into artificial reservoirs, water management companies, agricultural clients, industrial clients that they have space, when you do the full business case, not just the CapEx, but also looking at the benefits, the reduction in water evaporation, the reduction of algae, and the cost of opportunity of the terrain, that's where the projects can be more profitable at the beginning. The larger project, the utility scale project, of course, they are interesting. However, the development time takes longer. There are in certain states some uncertainties. We are seeing projects in the US that are being delayed because the utilities in the state, they are not facilitating the connection of the floating solar project to the grid because they know they are losing revenues from that happening. And so I think, you should bet on trying to do some of those projects, but if you only focus on those large projects, you really need to have a financial muscle to wait for a few years because it will happen, but it's not happening so fast as we thought it was going to happen in the US. The next question from Sachit, is there a concern that the two floats supporting one panel can move independently and cause bending stress on the solar panel frame? This is a very good question, and that's the reason why we cannot work with frameless PV panel, because it's impossible to eliminate the translation of some mechanical stress into the PV panel. And the testing that we have done in real life testing and also control testing show us we can manage that with the frame of the PV panel. And we can manage up to waves. We cannot manage with waves that are above 2 meters. Above 2 meters, there would be translation of mechanical stress. And in our case, we usually don't work in projects that are larger, that the waves are larger than 2 meters. That's the maximum that our technology is managing. We have had clients that want us to put our system in offshore, and we stay away from offshore because this problem would happen in those systems. But in artificial reservoirs or inland reservoir, we are not having that problem. Maximum wind speed. The maximum wind speed, and it's not just one maximum, the combination of maximum wind speed. The question is about the maximum wind speed that the system can manage. So if we look at that as an independent variable, you can go up to 210 kilometers per hour. But it's when there is a combination of wind speed plus waves plus currents. So usually what we'll recommend for, let's say, basic standard solution is 180 kilometers per hour. We have had cases in areas with hurricanes, 240 kilometers, that we don't propose. We don't believe the technology will last the 25 years that people are looking for. So maybe in the future we'll find other solutions that maybe they will be less competitive from a price perspective, but it's very, very relevant, the wind load in the system. The next question is also related with the two floats for each panel. So this one is already tested, and we have also certification from panel manufacturer that the system is compatible with those panels. Next question is about the commercial scale projects in the US and if we can support building permit application. So we have already some projects in development, commercial scale projects. large projects that can be projects in the 10 to 20 megas range that are in the early phases of development. The reason why we are setting up manufacturing facilities in the US is because we expect in the second half of this year that some of those projects will get the green light and we will start manufacturing with the system in the US. And we can support not directly doing the whole permit application. We support the company that you choose because usually the building permit application encompasses also electrical aspect, environmental aspects, and we can provide the information of the floating solar structure and the anchor and the mooring, everything related with the calculation, but this needs to be put inside a package that usually is done by third parties. The next question is on the warranty period of the product and what is the capex in euros per mega, if there are special floater for inverters and transformer, and the torque that we already talked about, the torque. So talking about those questions. Inverters and transformer. We have solution for inverters, and it's the same sort of float that we already have. In the picture that you see right now that I'm showing, you can see that there are inverters inside the island. You don't need to have any special additional floats. For transformers, it's a different story. For transformer, in the picture in the back of my head, here you have a plan where we put a transformer. In that case, we're using special pontoons. These pontoons are made of concrete and they are hollow inside, filled with foam, because the transformer is a much heavier and also taller structure. So the wind load of the transformer, it's even higher. We don't believe it's if you can put the transformer outside, if you can get the environmental permit, it's better. If you need to put it inside, we can provide solution. But we are also seeing that some environmental agencies, they are very concerned when you put the transformer inside the water because there could be oil leakage happening. If you need to change a transformer, how easy is that gonna be, if it's gonna be safe? So our recommendation is try to put the transformer outside. If you cannot do it, we can provide the solution for the transformer inside the water. On the warranty, the standard warranty that we are providing is 10 years, and we can increase the warranty if needed for the project at additional capex. And what the range of the capex? Well, it varies a lot depending on the reservoir and the size of the project. So if we talk about a 1 mega system, the floating solar structure could be ranging between 19 to 22 cents per euro. Or if you are talking about a larger system, a 10 mega system, the numbers might be going from 17 to 20 euro cents per watt peak. However, the largest variation is in the anchoring and mooring solution. Let's say an easy anchoring and mooring solution can be 2 cents per watt peak for a 1 mega plant. But if you go for dams, the most complex project that we have designed and quoted was in Latin America. It was a 125 mega in a dam with 96 meters of anchoring happening at the bottom and 45-meter water level variation. In that case, the anchoring and mooring cost went up to 9 euro cents per watt peak. So more than 4 times what would be in an easy anchoring and mooring solution. So we need to analyze each project case by case. Then the next question is related with the manufacturing. If we have the local manufacturing in the US and if we have a local office, yes, we have also a US entity. And the US entity, when we do business, you will doing business with a US entity. Next question related, if it's possible to put the system in seawater. Yes, it's possible. We already have installations in seawater. The challenge is not so much on the seawater effect on the PV panels. My recommendation is to look at the seawater effect on the electrical components and how to make sure that there is no corrosion happening. What is the IP of the PV panels? In that case, we would recommend using glass-to-glass panels and maybe the inverters well, to look for higher IP inverters. And also you will end up with higher cost of the electrical components because you need to make sure that they will be able to manage the corrosion. And if possible, we also recommend to put as much of the electrical components outside, not in the middle of the water. Something you can do it like inverters or combiner boxes, but maybe you will need to put them inside, and the cost of the OPEX also will be higher. The next question, it's what's the smallest subarray allowed, which allows approximation of non-rectilinear shorelines by different sizes of subarray. Anthony, I'm sorry, but I don't think I can answer your question right now. Let me offline try to get somebody from my technical team to answer your question.
Maybe I could ask it in a different way, because I'm sure I'll see this question shortly. What's kind of a minimum size that would be a cost-effective project? I'm sure we'll have maybe farmers that have water retention ponds themselves that might have enough space for 50 or 100 kilowatts. Is that going to be worth their while?
Okay, so I'd say, yeah, less than 100 we think is not cost effective. The cost of the design, transportation, anchor and mooring solution, the cost skyrocket, and this could be 50, 60 euro cents per watt peak only on the floating solar and the anchor and the mooring. Let's say that sweet spot where you start seeing some of the economies of scale kicking in and being more competitive is between 0.5 mega to 1 mega. That's where you already have, and you have more economies of scale, and that they kick in up to 5 megas. After 5 mega, there will be more, but the percentage of the economies of scale will be lower.
Got it. Okay, so maybe we can start focusing on larger farms that have sizable water retention. Beyond that, looking at more municipality scale reservoirs.
Yes, yes. Okay, the next question by Jeff is if it's recommended to install on the deeper or shallow part of the reservoir. So we would say that, as I said at the beginning, nobody thought that the Colorado River was going to run out of water. So if you want to be on the safe side, definitely go on the more deeper parts of the reservoir. And always look at the historical records of the water level variation, but you need to have a safety coefficient. And we have already cases in projects with clients that they had by law that the water level should never be lower than X level. But a very dry season came and water level went lower. It's nature. We cannot control nature. So try to design, if you can put it at places where you will have enough safety. So even if the minimum is X, you can say, okay, let's design with places that will be 30 feet lower than that, because you are covering, the probability will be lower. And also try to put it in places where the bathymetry show that it's not very steep, that maybe if it's resting at the bottom, it will not be in a big drop, in a big cliff inside, but there will be some bending happening, but it will not be significant. And that's what has happened in a couple of projects already that we have. What fraction of the overall surface area of the reservoir can you install a floating solar plant? 100%, 50%? So this varies mainly on environmental concerns. If you have an artificial reservoir where there is no aquatic life, and in fact they put chemicals to get rid of algae or fish because they use the water for pumping and you don't want anything getting the pumps, you can get close to 90%. You cannot get usually to 100% because there will be water level variation. You need a space for the anchoring and mooring happening, but you can get close to that. But if you have aquatic wildlife, we recommend to be lower than 50%. There are countries that they already have some regulation. They are moving around those numbers, 40%, 60%. So you need to look, and it's good that you work with authorities and you start with one project where you can show authority that there will no negative impact, and then you can start scaling the project. And try to, at the beginning, to be away from natural parks or places with significant wildlife, because maybe it's not that it's not going to happen. There will be a lot of opposition. You see it even in ground-mounted systems. There are ecological groups that are saying, not in my backyard, this is not good for the environment. Well, in floating, because there is less knowledge, there will be more people that they have not been able to be educated, and they might be against the project. So try to go for places with less wildlife. The next question is on the steps that should be taken if a potential opportunity arises. What should be provided in the initial stages and feasibility assessment? So the way we work is we can provide you, if you have a concrete opportunity, we can provide you with a checklist and a file that you can try to fill as much as possible the information about the reservoir, some of the variables that I've mentioned today, depth, water level variation, location, if you know that there are currents. With that, we can provide you an initial layout, a preliminary layout, and an initial cost estimation that you can put in your feasibility assessment. And if the numbers are okay, then you invest in having better information, maybe getting a bathymetry, getting a hydrodynamic study, or getting some geotechnical study. So the more information we have, the more precise the cost estimation we can provide. But we know, and we can support you during the development process to provide, as we progress, more detailed information as we get also more information from you. The next question from Jack is, will the panels be installed in an engraved slot in the floating pieces or installed on top of them? The panels are installed on top of the floats, and they will be installed by special clips that they are attached to the frame of the PV panel, and they are attached to the float by the use of rivets. We don't work now with screws and things. In the past, we used to work with them, but we saw that, again, that after several years, the screws tend to get loose. So we use rivets because they don't get loose, and they work much better also to support mechanical forces. The next question is the string wiring done and the type of material used as compared to ground mounted. The type of material is the same as high quality ground mounted strings. The way the string is done, this also varies by EPCs or by countries. There are places where they say that you need to do inline string wiring. There are also in other countries, they say that it's okay to do U-shaped string wiring. The system can support both. So we can do horizontal inline wiring or vertical inline wiring. We can do U-shape. So this will be designed together with you for the specific project, depending on the restriction that you might have or preferences. There are some EPCs that they prefer to do the string wiring a certain way. The system can accommodate those options. Next question is related with the logistic cost, and it's saying that the US is a rather large country, indeed, and so transportation cost is important. In which state or area will we have our manufacturing capability? So we're thinking that potentially this will happen in the area of Michigan, Iowa. That's because, first, there's a lot of knowledge from the automotive industry, a lot of machines, really competitive suppliers there, and it's kind of in the middle, yeah, and it has good, because of, again, of the automotive industry, there are good logistics going from and to those places. So that's where we are thinking that the manufacturing capability will be. And then the last question is from Anthony. Says, having installed a floating system with one of your competitors, it would appear your system is simpler. The connection don't require keeping track of which tabs need to be on top. More mistake-free, less to keep track of during installation. Yes, that is correct. And this is the current system that we have. It's simpler, but to be honest, it was not simple at the beginning. The first version of the technology 15 years ago, it was much more complex, and it was the experience and the problems of some of the old plants, the EPCs complaining about the productivity, and we have done a lot of things in these 15 years that we have improved. And the feedback that we're getting from our client and also from the EPCs is that they value the speed of installation, the reduction in risk, and some of the things that we do that probably when you have a large plant, it's when that will be relevant. For example, the floats, they come pre-installed, the screws to the float from the factory. So that's something that installer could do in the site, but we are doing in the factory so that you are reducing seconds for each screw. But when you're doing that, when you're putting screws, millions of those screws in a large PV plant, that's gonna have a significant impact in the reduction of the cost of your project. And I think those were all the questions. My contact details are here, and also through Kyle, you can have the information on our contact information. You can follow us, our LinkedIn page, where we're putting examples and information on the floating solar world and what are some of the new things happening and exciting projects that we are building. Thank you very much for your time. It's been a pleasure sharing, and looking forward to continue the conversation with whoever is interested in getting this floating solar world.
Thank you so much, Andres. That was fantastic. Really impressed. You answered 20 questions on the spot, back to back. You did a fantastic job. We've recorded this webinar, and we'll be sending a link shortly to the recording on YouTube. It's also going to be a Spotify podcast we have through our RENVU Energy Market Series, Apple Podcasts, and we'll also send an email with the promotions I had mentioned at the beginning. So keep an eye out for that, and you can always reach us at info@renvu.com.